That's better. Okay, so there's a whole bunch of people in the back room, and I want to freak them out. On 3, everybody just scream JavaScript, okay? Ready? 1, 2, 3. JavaScript! Whatever. Okay. So we're going to talk about mobile JavaScript. I'm not going to talk too much about PhoneGap, but I'm going to bring it up. I thought I'd do some contrarian shit first. So Akamai, who here has heard of Akamai before? They basically serve the internet. They're the edge network for any static asset on the web. And they just started shipping their data. And so people usually do these browser stats things that are kind of like smarmy and cheesy because you have to have a browser plugin, and they lie. So Akamai just started releasing their browser data. We only have about 3 months of it, but it's starting to show us stuff that we never thought before. So first thing, mobile's not first. And sadly, this guy is. But that's why I'm a mobile developer. So we're only going to look at mobile browsers. We don't have to worry about IE too much. If we look at Akamai's data for non-cellular networks, you can see that mobile Safari actually dominates, which is kind of weird. Android's slightly behind at 19%, and then oddly enough, Microsoft Mobile Explorer, whatever that is in 3rd place. Can I what? Oh, I have to hold the mic? Okay. Oh, sorry. You want me to dance? All right. All right, we'll do this. Okay, so this is on non-cellular networks. So this is mobile browsers not on networks. And if we look on a cellular network, everything's different. All of a sudden, Android is in 1st place, iOS is in 2nd place, and fucking Opera is in 3rd place. So, and BlackBerry is actually up there. And so the best I can decide on what happened here is that a lot of people have iPads at home. So the Buddha has this awesome saying where he's like, basically don't believe anything unless you have direct experience. And I really think this is applicable to any kind of software development. Looking at stats doesn't help you build your application. If you go by global market share, it's very unlikely you're going to actually have global market share. So I'm supposed to talk about mobile JavaScript. And there's a whole bunch of stuff going on in mobile JavaScript. And there's a lot of different things that can be done to fix mobile JavaScript. And I'm going to just power through it. So first thing, JavaScript frameworks. Who here is using a JavaScript framework for their mobile? Who's building a mobile app, actually? If you're building a mobile app, like, put your hand up. Cool. And if you're using a framework, keep your hand up. All right, sweet. So if you're using jQuery Mobile, keep your hand up. A couple people will admit that. That's cool. Anybody using Sencha? Yeah, a few people are using Sencha. Right on. So there's a lot of frameworks. They all have different philosophies. jQuery Mobile is kind of more like a declarative with the DOM. And Sencha is more declarative with JSON. See how that works out for you. I think you should try them all. I think they're interesting, but they're all pretty bloated, and they don't necessarily address all the devices they claim to address. So the thing you can do in mobile, though, is you can actually write JavaScript, and it works pretty well. So I tend to recommend just don't use a framework. Try and write JavaScript. Next big thing is offline. So has anyone here seen Jake Archibald's talk, App Cache is a Douchebag? It's a great talk from JSConf this year. It's hilarious. So the app cache has problems. It doesn't really work that well. And then there's web cache, which is local storage. It works super well. So those are your options, basically. In the networking world, we were having a lot of troubles. iOS 6 kind of broke HTTP. I don't know if anyone here has experienced or heard about that, but Guillermo wrote an awesome explanation of it on his blog. Oh, I should note, all of this is online. If you go to brian.io/LXJS2012, don't do it right now, but these are all links, so you can go like read this if you want. It'll tell you how to fix iOS. Touch events. Has anyone here worked with touch in the mobile world? It's a mess. So in iOS, it works really well. Android, there's full touch support, but you'll only ever get the first touch, so it lies. It's essentially broken. You can't do gestures or multi-touch. Windows Phone doesn't have touch events, and BlackBerry, it does work well. The good news is this has been solved about 1 billion times. So people complain about it, but there's this web page here where I think it was Paul Irish started this, and he just started collecting touch libraries that fix all the mobile situations, and there's tons and tons. So the moral of the story there is, yeah, touch is broken, but it's been polyfilled, so it's not actually a big issue. So Canvas and SVG, if you're building games right now, you're going to want to use these. You want to paint pixels. Problem is the performance in these situations isn't always good. We don't have garbage collection programmatically in JavaScript yet. So sometimes you can't build stuff that's really fast. Interestingly, IE 10 right now has the fastest canvas, which nobody would expect. IE 6 has garbage collection? Thank God. Okay, I did not know that. So the next thing is responsive web design. Is anybody here using media queries? Yay, media queries, responsive web design. So media queries are a really good idea. You basically define in your CSS, hey, only show this stuff on this type of form factor, and it works really well, except for you have to load all the fucking CSS before you decide what form factor you're on. So if you have a responsive website, you're still gonna load all that desktop CSS, you just don't show all of it. This isn't a really ideal situation if you're in a mobile world, because you wanna minimize your network traffic and you wanna minimize how much latency you have before things start up. The good news is Filament Group has created a whole bunch of libraries for fixing this. These are the guys that did Boston Globe. It's called South Street. The one that you want is called CSS Essential. I don't know if you can read that at the back, but don't worry, it's all linked up. South Street actually solves most of these problems. It also has a thing called Picture Fill, which kind of solves responsive imaging, sort of. So that's worth checking out. Whoops, there we go. Anyone use Flexbox? Okay, Flexbox saves your life in mobile. Basically, it gives you a proper grid. The only problem is the W3C went about defining most of it, and then they just changed everything. But it's vendor prefixed, and so all you have to do is change all your prefixes, and hopefully it'll work at some point in the future. But Flexbox, especially in mobile, is a way better way to lay out your applications. So I breezed through that part because I don't think any of that's actually interesting. It's practical and it's kind of useful, but you probably know about all this stuff if you're reading weblogs and following mobile in any way. What I really want to talk about is native versus web, or web versus native. This is an awesome picture. Someone told me it looks like Nicole Sullivan. I don't know if that's true. Anyways, she would laugh. So when we're talking about native versus web, the first thing a lot of people say is the web can't create great experiences. And that's bullshit. There's lots of great experiences on the web today. And yeah, it's hard to do, but say that you can't create a great experience using web technology would be a disservice to the practice of user experience. So if anyone says that to you, just tell them to shut up. The next thing just to consider, and I think this has already been well discussed this afternoon, but if we think about how an operating system's built, it's usually built in C. And if we think about how a web browser is built, they're usually built in C2 or C++. So it isn't really a leap to think that the web browser is actually capable of anything the operating system is capable. And Firefox OS demonstrates this really well, so does Enyo. If the web doesn't do something right now, it's not because it can't. It's not like it's impossible. It just means we haven't gotten around to it yet. Okay, so the problem though, and this isn't a big problem, but this is something that's going on today. In order for something to be on all these platforms in the browsers, we need standards. And this slide's a little bit goofy because I have a link under here to an awesome article written by Michael Rogers about the standards process. So W3C actually used to build a browser, and then all the browser vendors said, hey, don't do that, we'll do that. And that kind of got us into the situation we're in today. Standards still work, they just take a while. And so it's important though to note these standards have to happen. And there's a bunch of emergent standards that are really important. So the widget spec's actually not new, it's pretty old, and it's the idea of packaging web apps. We're using this in PhoneGap, we're seeing it be used in places, or similar things to it being used in other places like Firefox OS. It's worth checking out. The Device API Working Group defined a whole lot of stuff that we've implemented today in PhoneGap, and this is the stuff I'm most excited about. And there's a new group called SysApps, and this has actually been kicked off by Google and Mozilla, the web API stuff. System Applications Group is going to focus on, it hasn't started yet, they're just getting their chart together, the idea of an installable web app, but not just from the idea of what the APIs are, but what the permissioning model is going to look like. Today, if you load up Google Maps, it says, hey, can I use your location? And you're like, yeah, sure, that's cool. Can you imagine in the future if it's like, hey, can I use your location? Can I access your file system? Can I read your contacts? Can I see your accelerometer? Whatever. The model's not scaling, and so we're going to figure out a way to do this. We just don't know what it's going to be. There's some device APIs that we're really excited about, especially in the PhoneGap group. So Media Capture API, has anyone seen this at all? Tried it out? So this actually exists in almost every browser today. Media capture declaratively allows you to say input type equals camera, and then you can take a picture to a web page, which is amazing. You can also do audio. Kind of being superseded by it, this is actually Get User Media API, which is the programmatic kind of side of it. So you can programmatically say, hey, I want access to your microphone and your camera, which is awesome. Has anyone heard of WebRTC? This is another really big important thing that's happening today. So WebRTC is going to allow us to create real-time streaming peer-to-peer applications. Essentially, we could implement a Skype that's phone to phone. It also exposed another API called the Data Channel API. This hasn't really been implemented anywhere. It kind of works on Chrome sometimes, but it's super crashy today. I think we're going to see this probably in about a year, but it's worth keeping your eye on. So I work on PhoneGap. Have you guys heard of it? A couple people in the front. Sweet. We have two goals. Our first goal is the web is a first-class platform. I think this goal is actually shared by a lot of different groups that have spoken today. The web is not a first-class platform. We're in a lockdown sandbox. We're kind of at the mercy of all these different vendors with their proprietary tools and solutions and platforms. So we're trying to fix that. Our second goal is to cease to exist. And the idea here is that we want to implement stuff and then see it be picked up by the standards groups and then implemented in the browser. We have this huge API surface area. We didn't really mean to come across this, but we basically paint over the differences. And get it? We paint over the differences. We paint over the differences in all these different platforms. So our API today is focused on device APIs, and we cover a big gamut of things. It's actually really similar to the stuff you're seeing in Firefox OS and in Chrome OS. So capture, connection, network, battery. We're going to roll back our battery API because it drains the battery like a motherfucker. But that's another story. So has anyone here actually hacked on PhoneGap or built something with it? Oh, actually quite a few of you have. Have you ever checked out how it works under the hood? Okay, this is gross. I'm going to show you. So I don't know if I'm going to regret this. Not the Courage Wolf. Here we go. So I have a folder. It's called Cordova. Inside Cordova, I have a whole bunch of platforms. Let's start with our JavaScript, because that's going to be the most sane. So I don't know if you guys can see that. So our JavaScript right now, we have this lib folder, and then we have each platform that we implement. Now we have common JavaScript across most platforms, but the way PhoneGap works under the hood, we need to have a way of executing native code. And so in every platform, we have this method called exec. And so if I check out iOS's exec method, I kill this stupid sidebar. Okay, so we have this sort of common JS-like thing going on in our platform, but it's not actually. It de-sugars to an AMD style, which is kind of gross. So if we look at here, we got this sort of module exports. We got a little bit of error trapping. It's really quite boring. And we got all this stuff where we're logging callbacks, because essentially everything is a callback inside of PhoneGap. And then right at the bottom here, we have gap bridge source gap ready. So what's gap bridge? We look up here. It's a fucking iframe. So we first created PhoneGap, we found there was no way to communicate to the native code. But we also found that there was a URL. And so we figured out that you could trap any call to the URL with your own protocol handler, intercept it, do some magic, and then throw back to the callback. So this is actually how PhoneGap works in iOS. So if I show the sidebar again here, I'm just going to scroll down to our iOS source code. So that's the JavaScript side. And where's iOS?
Apple T.
Don't Apple T me. There it is. Okay, so in iOS we have this thing called Cordova View Controller. Let me kill my sidebar again. Hide sidebar. And we'll just do a very quick look for gap. Whoops. Gap colon slash slash. So there it is. Gap colon slash slash is really what's going on. So we're intercepting when we're loading a URL, and we're going to say, hey, if this is a call back to PhoneGap, grab it, and then execute or flush. So then there's a whole bunch of other stuff that happens here. Oops. Where did you go? Oh, this is a bad idea. It's like around 600. Flush. You gotta love Objective-C, it's so readable. Flush command queue, here we go. Flush command queue will actually evaluate string by evaluating JavaScript from string. This is Objective-C for eval. So we call eval, and we call our command queue, and then we can invoke code back on the JavaScript side. So that's how iOS works. Now I want to show you how Android works. So it would be nice if this worked the same way, but it doesn't because it can't, because it's just different code. So if I go into my lib folder in my JavaScript, we'll kill iOS down, and we'll look. These are all the platforms we support, more than anyone else, I might note. We have an exec method inside of our Android code. Hide this sidebar again. Okay, so does anyone see anything weird here? Check out line 24. It's a fucking prompt. So in Android, we could do the URL thing, but it was actually kind of slow. But we found that we could also override the Chrome stuff inside of the web browser in Android. And so we override the prompt, and we use the title of the prompt as our command queue dispatch. No shit. Now, I know you're also thinking right now, like, oh my God, this must be horribly slow. We're getting roughly around 400 or 500 operations per second. And I don't think anyone here needs to know their geolocation more than 400 times a second. So it is actually fast. But it's kind of ridiculous. So that's the JavaScript side. And then if I shut sidebar, jump into Android. On Android we have Cordova Chrome client, I believe it is. Yeah, JS prompt result. Yeah, here it is. Check out this beauty. So if the URL starts with file:// we'll just go load that. Somewhere in here it's going to say if it starts with gap:// show dialog. Oh, actually that might have been it. Else if, yeah, gap callback server or gap pull. And if it is, then we dynamically load the Java class, we grab the result, we serialize it to JSON, then we eval it back on the other side. So this is pretty hairy, admittedly, and it works. This is the other thing to keep in mind. And so if you start thinking about how Cordova works, basically every Cordova platform, or every PhoneGap platform, has an exec. An exec takes a few functions, a success function, a callback function, and then a bunch of parameters. If we consider this, it's like asynchronous I/O, which kind of sounds like Node.js. So after Patty's talk, I was pretty stoked because I didn't think Node was really considering mobile. I know that there's a proof of concept on iOS, and actually I did know about Patty's project. In theory, in BlackBerry 10 and Windows 8, we're going to also have the ability to compile arbitrary native code. And so Node would be a perfect platform for us to get rid of these ugly hacks. So this is more than anything just a call to the Node guys that are here to help us. Again, in theory, it's the key. The other thing to note, BlackBerry and Windows, meh. Okay, so this is another thing that's happening right now, and I'm not totally sure what it means. Whoops. There's something called Tizen. It's a collaboration between Intel and Samsung. Tizen essentially is WebKit on top of the Linux kernel. WebOS is going open source apparently. We've been hearing about that for a long time. Windows 8 is all about the web. If you check it out, it actually has a pretty decent API. Mozilla has boot to Gecko. There's Chrome OS. Whatever the case, JavaScript is going to be absolutely everywhere. All of these major players are making a bet on web technology as an installable web apps. So the conclusions are pretty inconclusive. We know the mobile situation is definitely messy, but all these libraries and all these problems, things like touch, it's been polyfilled. We've solved this stuff. We don't have to worry about it. There's stuff to do here, but most of it is now in place. Device APIs are starting to come to all these platforms, and we're seeing increasingly more and more powerful web browsers. Node.js is going to be an important technology, I think, for mobile moving forward. I'm hoping that the project can get on board. And it looks like web operating systems just might be the future of mobile. That's it.